Warm up for lesson 6-2. Pause to do the problem. And here's the answer. This is a practice for composition. Pause. And again, another practice for composition. Pause. This is quite an interesting question and standardized test practice. This is asking us to do something very interesting. We have to take a look at something equivalent to f of g of 1. So I first found f of g of x. I put g into the f function, and I found my brand new function. I put 1 into my brand new function and found this is my answer. So I'm going to look at all my choices and see when I get -2. Now, as soon as I put 1 into my f function, I got -2. So I got the answer right away. I found that this was equivalent to the a. But I was still curious, and I found g of 1. So I put 1 back into here, and I put f of 0 back over here. So they weren't matching, but I was curious about this one. So I found g of f of x, the function. This is my brand new one. I put a 1 into the brand new function and got a 4. So I'm assured that A is the correct answer. Lesson 6-2, Inverse Functions and Relation. Objective, find the inverse of a function or relation. Determine whether two functions or relations are inverses of each other. Okay, an inverse relation. An inverse relation is such that one relation contains, and let's go ahead here, it contains the point AB, and the other relation will contain the point BA. So they're going to switch x and y. So here's an example of two inverse relations. Here's 1 and 5, 1 comma 5, and the inverse relations 5 comma 1, and so on. Now we've seen this inverse relationship with reflections over the y equal to x line in geometry. Okay, whenever it reflected across y equal to x, our rule was x comma y maps to y comma x. That was the rule for reflecting across the y equal to x. All right, let's go ahead and see if we can find an inverse relationship. Here's the picture, and here is the inverse relationship. It'll have a point 3 comma 1, and all I did was take the x and the y and I reversed them. 3 comma 6, 0 comma 6, and 0 comma 1. This is an inverse relationship because it's going to be a reflection across the y equal to x line. All right, inverse functions are related, are also related. We see them so often that we have a special notation for an inverse function. We call this f inverse, or the inverse of f. Now, f of a equals b means the point if you send a in, you get b out. And the inverse relationship says if you send b in, you get a out. So this is an inverse relationship. Let's take a look at two functions. Here's a function here, and here's another function that they call the inverse. Let's see how that plays out. We're going to send the number 6 in. Everywhere we see an x, we're going to write 6, and what we come out is the number 2. Now, they're calling this an inverse relationship. We're going to send the number 2 in to this inverse, and you're going to get 6 out. So when this happens, we say that these two have an inverse relationship. Okay, when is an inverse a function? Let's go ahead and go to our calculator and let's talk about this. I am going to put a function in my calculator. I'm going to put x to the third power plus 2, and then I'm going to go ahead and graph it. I'm going to zoom square when I do that. So here's my function right here. Now it is a function because it passes the vertical line test. Now our calculator will draw the inverse. So I'm going to go second, draw, and then I'm going to go here to where it says draw inverse. So I'm going to choose 8. Now it says, what do you want to draw the inverse of? And I'm going to say, I want to draw the inverse of y sub 1. So I paste that on, and then I press enter. And now it graphs. Now I want you to notice that it's that same idea of a reflection across the y equal to x line. Alright, so I'm going to go ahead and take away the drawing. So I'm going to enter here. And then I'm going to go back to y equals. And I'm going to write another function here. And I'm going to write x squared plus 2. Okay, and I'm going to go ahead and graph it. Now this is also a function. It passes the vertical line test. And I'm going to go to second draw. I want to go to 8. And I want to draw y sub 1. And then I'm going to enter. Okay, now I'm getting another parabola sideways. Unfortunately, this is not a function. It is a relation. So even though there is a reflection across the y equal to x line, the inverse is not a function. So let's go back to this. When is an inverse a function? Let's go to the next screen. The inverse will be a function as long as it passes what we call a horizontal line test. So in here, if the function, this is definitely a function, if the function passes a horizontal line test like this, then I know when I graph it, the inverse will also be a function. Now here, the horizontal line hits the graph in more than one place. So it's going to be like the parabola. When I do the inverse will not be a function. It'll be what we call a relation. Alright, find and graph an inverse. So here are the steps to finding an inverse. What we're wanting to do is we're trying to create a function that reflects over the y equal to x line, y equal to x. So step 1 is to rewrite the function so that you're using just x's and y's. So we're going to take this function f of x and we're going to just make it a y instead. Step 2 is to exchange x and y, and that's what we did in geometry. We would just exchange x and y, and that's what we've done here. The x now changes, the y changes to an x, the x changes to a y. And then step 3 is for you to solve for y. So we're going to use our algebra skills to get y by itself. Now that we've gotten y by itself, we're going to replace the y with f inverse notation. So here's the notation, and right here is our inverse. Now, when we go ahead and graph it, when we go ahead and graph this right here, we can see there's that wonderful reflection across the y equal to x line. Let's look at another example before we do one by scratch here. So step 1 is to rewrite, so we're going to take this out and put a y in. Next step is to exchange the x and the y. You see the y is now an x, the x is now a y, and now we have to solve for y. So we've got to get y by itself, bring the 1 to the other side. Here is y. To get rid of y, you're going to have to write plus or minus root x minus 1. Okay, and then we're going to take the y and we're going to replace it with the inverse notation, but all they did here was just write y here. And when you graph it, you can see that this is a relation. It's not a function because it doesn't pass the vertical line test. All right, let's go ahead and practice from scratch. Okay, so step 1 is to write this in with a y. Y equals x minus 3 over 5. Okay, step 2 is to exchange x and y. So wherever there was a y, you write x, and vice versa. So this is going to be equals minus 3 over 5. Now we want to solve for y. I'm going to do that by multiplying both sides by 5. And then I'm going to move the 3 to the other side. And so now I know y I'm going to call f inverse, and that's going to be 5x plus 3. Now I already graphed the original, now I want to graph this one. So we're going to go 1, 2, 3, and then I'm going to go up 5 units, 1, 2, 3, 4, 5, and then over 1. And then I'm going to go ahead and draw my line. And you can see there's that wonderful reflection idea here. Okay, let's go ahead and do the same thing here. I'm going to change that to a y, 3x squared. I'm going to exchange x and y, and then that's going to be equals 3 to the second power here. Now I want to solve for y, so I'm going to divide both sides by 3. And then I'm going to solve for y by writing plus or minus root x over 3. Okay, and then so root x over 3, I know that if I graph that first, it'll be a 0 here. And then if I put the number, like say 3 in here, so I go over 3, 1, 2, 3, I'll go up 1. And it'll graph something that looks like that. And if I graph the negative version of it, it'll graph something like this. And so again, that's a wonderful reflection here. Okay, let's pause and see what you can do to find the inverse. Even if you don't graph it, just find it. And here's the answer, going through the same steps that I outlined before. Okay, verifying inverses. How can you tell whether something's an inverse without just going through the process of finding the inverse? Well, there is a faster way, and the fast way is you can take the two functions and take their composition both ways, take the composition this way and this way, and if they yield x, then we say they're inverses. The idea of an inverse is the undoing process. So if two things are undoing each other, you're going to get back to x. You're not going to have any multiplying or dividing or adding or subtracting. Let's look at this example. Okay, so this function f is multiplying by 3 and then adding 9. This function is taking a third of x and then subtracting 3. We want to see if they are inverses. We want to see if they undo each other. Okay, so I'm going to do f of g of x. So everywhere, here's my f function right here. And I'm going to write 3, and inside the 3 I'm going to write my g. And when I simplify, I'm going to get x. So all the multiplying and adding are undoing each other, and we're just getting x. We're just getting that reflection line right there. Now if you do it in g of f of x, and you put your f of x into g, so everywhere there's x, you're going to write that, and you get an x again. And when this happens, then that means they're undoing each other. All the multiplying and subtracting, multiplying and adding are undoing each other. And we say that they are inverses. They undo each other. Now let's take a look at another example where we do f of g of x, and we're going to send g, right here, we're going to send g into our f function, and we don't get x, so you don't have to do anything anymore. We know they are not inverses. You don't have to bother checking anything else. All right, let me do things by scratch now. I want to find if these are inverses, so I'm going to try to find f of g of x first, and I'm going to write out my f, 3 parentheses minus 3. So what goes in parentheses is my g. So this is what's going to go in there. So it's going to be 1/3 x plus 4. I'm going to go back and simplify. So this is x plus 12 minus 3. And I am going to get x plus 9. Okay, so that looks like it doesn't work. No, not inverses, because I didn't get an x in there. All right, now let's go ahead and go to this one and see if they are inverses. F of g of x, And so I'm going to take my f function and I'm going to put parentheses in there. And on the next line, I'm actually going to substitute. And I'm going to substitute root x plus 1 over 2. Now, I know a square root and a square will undo each other. So I am just going to have x plus 1 over 2. When you have a square root like this and you square it, you are going to just get rid of the square and the square root. And then minus 1. Okay, so these 2's are going to reduce. And I'm going to have x plus 1 minus 1. And that answer is x. This looks good. Now, if I go ahead and do the other and get the x, then it's going to work. So I'm taking my g function, and everywhere I see an x, I'm going to write a parentheses. And what I'm going to put inside of it is 2x squared minus 1. All right, and then I'm going to get the square root 2x squared minus 1 plus 1 over 2. The 1's are going to go to 0. I can do a little reducing with the 2's. And I'm going to get square root of x squared, and I know that becomes x. So I got x in both cases where I took a composition, so the answer is yes. They are inverses. Let's pause and let you try. And here's the answer.